Hey folks, how's it going? It's Mr. Murray coming to you with a little do now for Friday, May 22nd, 2020 for Course 2 Honors. And welcome to the end of week 9. Isn't it crazy how quickly time flies? We're going into week 10 in just a few days. So as we head into Memorial Day weekend, I do have this little do now for you. So yep, you got it. My games continue. And this one is called Deal or No Deal. No relation to any possible game with any kind of similar name, right? So you're dealt one card randomly from a deck. It is not replaced. You are then dealt another card randomly from the deck. Okay? If the cards add up to 11 and are different colors, you win. So the values have to add up to 11 according to these numbers here, where ace is worth 1 or 11. The number cards are worth whatever number is on them. And then jack, queen, king are each worth 10. So for example, a jack and an ace, a 9 and a 2. Those would be examples that win. But they also have to be different colors. So for example, a 2 that's black and a 9 that's red. A 9 that's black and a 2 that's red. It doesn't matter the specific suit, but one of the two cards has to be black and one of the two cards has to be red. It also doesn't matter which order it is in. So it can be red, black, or black, red. Okay, the only two conditions are you have two cards. Well, there's three conditions. The first card is not replaced once it's taken out. Okay, you have the fact that the cards need to add up to 11 and they must be different colors. So determine each probability. First, the probability that you win given that the first card is a red jack. So given that the first card you get is a red jack, what is the probability that you win? The second one is, what's the probability that you win given that the first card is a 5? And this is a challenge one for the third one. What's the probability that you win given that the first card is a spade? Remember, this all comes down to the fundamental idea of probability. The probability that an event occurs, if we call the event E, is the number of elements in that event over the number of elements in the sample space. It's just now the sample space has been adjusted because an event has already occurred. We've gotten the first card and it's a red jack. We've gotten the first card and it's a 5 of some sort. And we've gotten the first card and it's a spade. Okay, so please take a moment, pause the video, attempt to calculate these probabilities. Fraction is fine. Then when you're ready, unpause and you can see what I got. Okay, folks, so here we go. We're going to try to take a shot at answering these questions here. So my first probability question is, what is the probability that I win the game given that the first card was a red jack? So essentially what we know is this. I know that I'm drawing two cards. I'm not putting the first one back. But I do happen to know that it's given that it has to be a red jack, meaning I either got as my first card the jack of hearts or the jack of diamonds. Okay, so what that essentially means is, okay, we have to think about, well, how many possibilities could we have involving those two cards? Well, if you imagine grouping all of the cards up, kind of like how we grouped the dice up into a table, right? So I could have the jack of hearts combined with any of the 51 other cards. So there's 51 possibilities where you have the jack and the other cards. And then there's also 51 possibilities where you have the jack of diamonds and the 51 other cards. Okay, and so remember, the sample space is all of the possible outcomes that could happen. And because the first card, it's given that it's a red jack, right? Then the only possibilities that could happen are the ones in which the first card is the jack of hearts or the jack of diamonds. Okay? Because ordinarily, right, for any card you choose, okay, there's essentially 52 cards to choose from, right? And then for each card, there's 51 other cards you could pair with it. So this is the total number of pairings, but we only want the ones where the jack of hearts or the jack of diamonds comes first. And so there's 51 plus 51 of those. Now, of those, which are going to win? Well, I can either have the jack and the ace of spades, the jack and the ace of clubs. So I've got, actually, I should be clear. The jack of hearts, the ace of spades, the jack of hearts, the ace of clubs, the jack of diamonds, the ace of spades, or the jack of diamonds, the ace of clubs. And that's for two reasons. First, we need to add up to 11. So only ace could do that because only ace offers that option of 1. And then it has to be a club or a spade because remember the two cards have to be opposite colors. So because the first card is red, the second card must be black. So that means there's 1, 2, 3, 4 different possibilities that are the ones we want, the wins, out of 51 plus 51 possible combinations where a red jack is first. So that's 102, and we have 4 on top, and that would be 2 out of 51, or approximately 4%. So that is to say, if I was to draw a card at random, given that the first card that I drew was a red jack, I would have a 4% chance of winning. Now, if the first card is a 5, how does that change? Well, the way it changes is this. Because I didn't specify the colors, right, there's now 4 possible things that we could have started with, right? I only told you the first card was a 5. I didn't tell you which one it was. So that means the first card could have been a 5 of clubs. And if it was, right, it could have been the 5 of clubs. And once you have the 5 of clubs, right, you could pair that up with any of the 51 other cards, including one of the other 5s, right? You could have the 5 of spades paired up with any other card. You could have the 5 of hearts paired up with any other card. And then you could have the 5 of diamonds paired up with any other card. But which ones will win? Well, once you choose 5, because you need to add up to 11, the only winning cards are going to be the 6s, because 5 plus 6 is 11. So what possible combinations could I have on this one? Well, if I choose the 5 of clubs, then either the 6 of hearts or the 6 of diamonds will win it. If I choose the 5 of spades, either the 6 of hearts or the 6 of diamonds will win it because those are the red 6s. If I win the 5 of hearts, either the 6 of clubs or the 6 of spades. And if I get the 5 of diamonds, either the 6 of clubs or the 6 of spades. So I could get this combo, 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 or that one. So that's 8 combinations in which you have the first card as a 5 and the second card as a one that would cause you to win. That is to say, they add up to 11 and they're opposite colors. And those are the 8 winners. And there were 51 plus 51 plus 51 plus 51 total possibilities to begin with. So what we want is 8 out of 204. And 8 out of 204 is the same exact thing as 2 out of 51. Okay, because you divide the top by 4 and you divide the bottom by 4. So interestingly, we're equally likely to have a winning outcome here. Why is that, folks? Here's the answer. Yes, there are more ways that you can win when you have more cards, but that was balanced out by the fact that I added into the sample space. So yes, I added into the numerator, but I also added into the denominator. So that's why that happens. But what you need to be focusing on is counting the things we want over the total number of possibilities, and remembering that that's being limited by this condition. Last one, the probability we win given that the first card is a spade. And I put this as a star because this one is a major challenge. So for the spades, now what we know is that there are 13 different spades, right? Ace through king. So I could get the ace and the 51 other cards as combinations, right? Ace and ace, ace and two, ace and three, blah, 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 blah. Ace and two, ace and three, ace and ace, ace and two, etc. So I could have the ace and the 51 other cards. I could have the 2 and the 51 other cards. I could have the 3 and the 51 other cards. I could have the 4 and so on and so on and so on, right? Because we're trying to find all the possible combos. So I have 13 spades times 51 other cards that each of those spades could pair up with. That is my sample space. Now, if the first card is a spade, now here's where it gets tricky because we've got to think about what possible combinations are winning combinations. So now what we have is this. We have the ace of spades could go with the jack of hearts, the queen of hearts, the king of hearts, because all of those are one. And the jack of diamonds, queen of diamonds, king of diamonds. I'm going to do this for only one, right? We only have to worry about the ace of spades, right? Now the clubs don't really matter anymore because none of the clubs are allowed to come up as the second choice, right? And the reason that is because you're not allowed to have two cards that are the same color, right? One is black, one is red, and they add up to 11. Okay? Now, the 2 of spades has to either match up with the 9 of hearts or the 9 of diamonds. Okay, the 3 goes with the 8 of hearts and the 8 of diamonds, the 4 with the 7, the 5, and so on, till we get to 10. So I guess also we have to include the 10. Okay, so when we get to the 10, the jack, the queen, the king. Now we assume that the order does matter. Okay, especially because it matters that you have this one first and that one second. So the 10 has to either go with the ace of hearts or the ace of diamonds, and that's true for the queen, the jack, and the king. So let's look at the combinations. The ace of spades, there are 1, 2, 3, 4, 5, 6, 7, 8 possible for the ace of spades. Then for the 2 of spades, there's 2. For the 3 of spades, there's 2, 2, 2, 2, 2, 2, 2, 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's 18 more combinations, right? So 2, that is to say, right, 2, 9, 2, 9, 3, 8, 3, 8. So you can actually see those combinations working out. Now for the 10, jack, queen, king, those each have themselves another 2, right? The 10 and the ace, the 10 and that ace, the jack and that ace, the jack and that ace. So that leaves us another 2. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24. So instead of so this is what we really have. Let's really count it up. All right, so we know that the ace gave us 8, and that's because there was 4 that it could have gone with, because it's a 1, and those are 10s, so there's more ways to match those up. So 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So 32 possible combinations out of 13 times 51 different possible solutions. So what I'll do is I'll do 32, I'll do rather 13 times 51, 663. So it's 32 out of 663. Now you should be careful to see if there's a format they want us to leave it in. They don't specify it needs to be in a percent, but that is something you'd want to look out for, and then you would use your calculator to figure that out. So hopefully you're all able to get this correct. If so, congratulations. Please make sure you check out the stuff for today as we're going into Memorial Day next week, and it's going to be kind of a quick wrap up to the unit. But best of luck. Don't forget to love math, and remember, you can do it.